Hi everyone, in this particular video, we will be discussing the problem Pascal's triangle. Let's just directly jump onto the problem statement. We are given a non-negative integer num rows, that is in the input, the integer is given, which is a non-negative integer. It means it will be either 0 or it will be greater than 0. And in the constraints, as I can see, is n will be less than equal to 15. The n is nothing but number of rows only. So number of rows will be from 0 till 15, or you can assume from 1 till 15. Generate the first num rows of the Pascal's triangle. We have to generate the first n rows. Let's say num rows is equal to n. First n rows of the pattern which is known as a Pascal triangle, and we have to return that triangle. Pascal triangle is a pattern in which a number in a row B is the sum of the number exactly above it A and the number to the left of A, which is known as C. Every element will be sum of two elements, the element just above it and the element just to the left of the above element, or you can say to the top left of the current element. And the pattern, as you can see, if there are 5 rows we have to construct for this pattern, for this Pascal triangle, the pattern will start from 1, because obviously for the first number there will be no top element, there will be no top left element. So for the first element it will be fixed. For first row it is only having one element, which is 1. From next row you can apply this strategy, and as you can see in the sample output, in the first row there will be one element, in next row there will be two elements, in next row there will be three elements, then four elements, then five elements, and so on. The number of elements will keep on increasing as we are going to the new rows. So let's try to generate the same pattern for n equals to 5 using some idea, using some approach, which the problem statement itself is describing. That is, every element is sum of the top element and the top left element. So as you can see in the row 1, as I have already told, the element will be fixed, which is nothing but 1. Then for row 2, what will happen? We can say for the first element, there is a top element, there is no top left element. So for now, we can assume it is 0 if it is not there. And what will be the sum of these two elements? 1 plus 0 will be 1 only. Or you can assume it is initially 1 only. Start with 1. As you can see in the sample output, every row is starting with 1. But next element, for this element, again, there is no top element, but the top left exists. So 1 plus 0, if there is nothing, we can assume it is 0. So 1 plus 0 is again 1. So in the next row, two elements are there, both are 1. For row 3, how will we construct the pattern? We can say for this element, top element plus top left element. 1 plus 0, if there is nothing as 0, we have to assume. So 1 plus 0 is again 1. But for this element, 1 plus 1, this time it will be 2. For this element, because every row will have one more element, top element is 0 because it is not there. Top left is 1, so 0 plus 1 is again 1. So third row is having 1, 2, 1. What about the fourth row? How many elements should be there? 4 elements should be there. Row 1 having 1 element, row 2 having 2 elements, row 3 having 3 elements. Row 4 will be having 4 elements. What will be the values? First element, 1 plus 0, 1. Second element, 2 plus 1, 3. Third element, 1 plus 2, again 3. Finally, last element, 0 plus 1 is 1. So these are the fourth row elements. And let me also construct the fifth row, because n was 5. So we have to construct 5 rows. So for row 5, the same strategy will follow. That is the top plus top left, 1 plus 0, 1. Top plus top left, 3 plus 1, 4. Top plus top left, 3 plus 3, 6. Top plus top left, 1 plus 3, 4. And finally, top plus top left, 0 plus 1, 1. So this is the entire pattern. And we have to not print it, but we have to return it. We have to return it as what? As a data structure. What should be the data structure? Although it is mentioned in the return type, but can you figure out by your own? Since there are multiple rows, each row will be consisting of one list of data, or you can say an array of data, a dynamic array, because array size is different for each row. So every list will be contained in an overall 2D list. So it will be nothing but a list of list. What we have to return is nothing but list of integers. Or you can say it is nothing but a 2D array, but a dynamic kind of 2D array, where every row is having different number of columns. First row having one column, then two columns, then three columns, and so on. But how will we construct it? As already mentioned in the problem statement, since new row should be constructed using previous row, The current element is sum of previous two elements. We need the previous row values to generate the new row. So we will at every time maintain the current row which we are generating, and we will also try to maintain the previous row which is we have already generated. And using these two rows, the previous and current, we will generate the entire pattern. So what we can do is for the first row, or actually for every row, the first element is 1. So what we will do is, as soon as we are starting from any row, we will say that first let's insert a one element in that row, in that list of elements, a dynamic array. And we will insert those many elements which is equal to the number of row index. If row index is 1, we will insert one elements in total. So since we have already inserted one element, we will just say this is the first array list. Done. The first list of elements is done. Now for the second list, how we can generate it? We will say that second list should contain finally two elements. First element is of course 1, so don't need to do anything. Don't need to just say that take the previous two elements or something. Just directly insert 1 in the first. Then we will say from next element onwards, we will say, let's have a formula. And what is the formula now? We can say it will be the previous top left element and top element. That is 0 plus 1. If top element does not exist, take it 0. And the top left element, which is 1. So 0 plus 1 is 1. And so on. So if this is your previous list, how will the current list be formed? The current list will be saying that current list will be having first of all 1, or you can also apply the formula for this one, that is top element plus top left element if both exist, but top left does not exist, so take it 0. 0 plus 1, 1 plus 1 2, and 0 plus 1 1, and so on. So previous and current, both of these lists will keep on updating, and we will be able to finally form the entire 2D list of lists. So let's go to the code. Actually, let's write the instruction manual. But before discussing instruction manual, what do you think will be the time complexity in order to solve this question? As you can clearly see that we will have one element in first row, two elements in second row, then three, then four, then five. Total, how many elements will be there? 1 plus 2 plus 3 up till n, because there are n elements in last row, 5 elements in fifth row, which is nothing but n into n plus 1 by 2. And in order to calculate every element, we just need what? We just need a sum of two elements. So it is constant time. So overall time will be n into n plus 1 by 2, which is order of n square only. It will be quadratic time. And what about the space? Since we are going to take this matrix of matrix, actually not matrix of matrix, but list of lists. For output, we can say there is a space that is nothing but n square, same. But if I will consider extra space, we are not taking any extra space. So extra space is constant. Output space is order of n square, which is this list of lists which we are about to return. So depending on whether we have to include the output or not, you can answer accordingly. Okay, so let's go to the problem link and let's write the third milestone, that is the instruction manual. So first of all, we will make a 2D list, Let's say the 2D list is, we will say it is the Pascal triangle. Let's say the 2D list is named as Pascal triangle, which will be initially empty, which will have 0 rows. Make a 2D list Pascal. And now we can say what? We can say this 2D list, of course, will be of integers. It will be a list of integers. Now we will run a loop for every row. We will generate every row. So run a for loop. For every row. Starting from for every row from 0, the 0th row, actually you can say first row, not 0th row. From first row till what? Till the nth row, till n. And once we are for sure that what is the row index, we can say now the columns will be for the row number of times. So run a for loop to be precise, for every column starting from 1 but going till the row index, because first row having 1 column, second row 2 columns, third row 3 columns, and so on. So this is the loop for columns. For every row we make a new 1D array list. So make a 1D list of integers. Let's say this is the list. Let's say this name we are saying is nums. You can name it anything actually, or let's actually name it current. And we will also say that actually get the previous array list, get the previous list of integers, which is nothing but previous, which is the last array list in the 2D list. Previous list of integers from the Pascal triangle. The previous list, which is the last list from the Pascal triangle. And if it is not there, what we have to do is we have to take it as an empty array list, or we can say we have to take it a list of zero styles. So we will be running a for loop for every column. We will be saying what is the current value going to be? The current value will be the sum of values directly above it and the value to the top left. So directly above it will be the previous row, same column, and top left will be the previous row, but column -1, that is previous column. So we can say store or add a value, which is add value as the 2D lists, that is Pascal's what? The Pascal's previous rows, same column value, that is columns index, and the column -1th index, Add these two column values, the corresponding values present in the previous row, into the current row, into the current list, in the nums list. And we are just having a corner case that if note, we can say just add a note that if the value does not exist, take it 0. If value does not exist, take it 0. So this is important point. And finally, once we are able to inform the entire list, we will add the current list into the 2D list. So add the 1D list nums in 2D list, which is Pascal. And finally, once we are able to form all the rows, we will return the 2D list Pascal. So this is the entire approach, the pseudocode or the instruction manual. And now we will be doing the milestone 4 and 5, where we will write the code in particularly Java language. And we will also discuss about various corner cases or the time and space complexity which will be involved. So first we have to do what? Since we have to return a list of lists, that is a 2D list, we have to make it. So let's create a list of integer in Java by using list, angular brackets, list, angular brackets. Let's say the 2D list is named as Pascal. And how to initialize a 2D list? We have to initialize a 2D list using array list only. You can also do it actually using linked list, but array list is the most simplistic implementation. So even if it is 2D list, still it will be getting implemented by a array list only, because 2D list is also a list only, list of list. So we have declared a empty matrix, a empty Pascal triangle. Now we will be running a loop for all the rows, starting from the row first, going till the row nth. So we will run a loop for all the rows from row 1 till row less than equal to n, that is n rows in total. And every time what we have to do, we have to generate a new row. In order to generate a new row, first we need the previous row. How we can get the previous row? We can ask from the Pascal triangle only. That is from Pascal, get the last row, which will be the previous row. And if last row does not exist, take it empty. So we are saying that take the list of integer previous is nothing but your Pascal dot get last row. So what will be the last row? It will be the Pascal dot size -1, the number of rows -1. Last row will be having number of rows -1 index. But if such a row does not exist, that is, if the current row is the first row itself, then we have to take the last row as actually nothing, empty. So in that case, we have to take it empty. That is a new array list. Otherwise, we can take it as whatever the current previous row will be. That is Pascal.get Pascal.size -1. Once we are getting the previous row, we also have to make a current 1D list of rows. That is what is the nth row, so that we are generating the new row with the help of previous row. So current row will be initialized with the empty array list also. And to generate all the values of the current row, we will run a loop for the columns. That is for all the elements of a given row. We will run the loop, but column, as discussed in the approach video, will be running for row number of times only. Why? Because in first row, there are only one column in total. Second row, 2 columns. Third row, 3 columns. Fourth row, 4 columns, and so on. So column loop will be running till row only. And how to generate the value of a new cell? New cell will be just nothing but add the previous 2 nodes. So in the question itself, we can say every new number will be the number exactly above it and the number to the left of the number above it, that is top left. So first, if I say the top value can be nothing but the previous row's same column value. So previous dot get the same column value if it exists. Otherwise, if it does not exist, how we can check if it does not exist? If obviously columns are lesser than what we need. If let's say the column is equal, or maybe if column is more than equal to the number of columns in the previous row, previous dot size, in that case we can't get the previous row, so we have to take it 0 as discussed in the approach video. If it does not exist, then we have to take it 0. So if column which we are trying to get is more than the size or equal to the size, take it 0, otherwise take the previous cell. And same for the column minus 1th cell, so that is top left cell. So maybe let's take this is x, let's take this is y. So y will also be if column minus 1 is greater than equal to previous dot size. In that case, don't take it, take it 0. Otherwise, if it exists, then we can take the column minus 1. But also there is one more thing, that column minus 1 should not be negative. So actually column minus 1 will never be greater than equal to previous dot size. We can only check for whether it is negative or not. If it is less than 0, then we can't take it. Negative index does not exist. So once we have taken the top value and the top left value, we can add it in the new cell. So we can say add the current value as the Pascal's current row comma column index. That is, in the current row, add the cell which is x plus y. Add the value that is sum of x plus y, the top and the top left cell. And finally, once the entire loop is done, obviously if we are not adding the 1D list into the 2D list, the entire logic will not run and the output will be empty. So what we will say in the Pascal triangle, add the current row. This is how we will do the entire Pascal triangle dry run or the Pascal triangle nested loops. Let's just run the code and see if it is working fine or if there are any corner cases which are not handled. So it is taking some time to run. Let's wait for it. And there is some spelling mistake, most probably. The line number in the line number previous, where we are declaring the previous, if row is nothing but equal to 1, then we are having a new array list and it should not have semicolon. Only the colon should be there. By mistake, a semicolon was added. Nevertheless, if I will run it again, so it can't find the symbol n variable. So n is not declared, but what is n? N is nothing but num rows. So we can just rename the variable num rows to n, because in the constraints itself it was mentioned n. N is nothing but the number of rows of the Pascal triangle. So it is still running into some issues. Of course, let's try to do a dry run. Index 0 out of bound for length 0. Index 0 will not exist for a length 0. So most probably, whenever we are running a loop for columns, what is happening? We are starting from 1, going till row. But actually, when we are trying to store the values, what are the indices being used? The indices will be 0th index, 1st index, and so on. That is, this value, if I just remove all of this first row will be having column 0, then 0 column, first column, 0 column, first column, second column, because always the indexing is from 0. So what we have to do is, one change which I can think of is, instead of running the loop from 1 till row, we can run the loop till 0 till less than row. That is from 0 till row minus 1. Although the number of times loop will run will be same, but due to providing the same indices, we have to do it. There might be still some issues. Let's try to run it and see what are the other issues happening. So we have already changed the variable name as n. Let's make it n only, and let's try to run again. What are the other issues happening? Let's try to see. So we can say that all the outputs are becoming 0. And we discussed this point in the approach video also. That is, in the first row, the starting value is 1. It is not 0. Because if you will try to take 0 plus 0, it will remain 0. And all the values will keep on becoming 0. For when we will try to add 0, 0 plus 0, x plus y, when x and y both are 0, don't add 0, add 1. So there is a corner case. What we have to do is, if row is the first row, in the first row, the value is not 0, the value should be 1. So don't add x plus y, don't just directly add hard-coded 1. Otherwise, add x plus y. If I will add this if condition, let's try to see what is happening for n equal to 5. It should give me the same Pascal triangle right now. And as you can see, the expected output is the same as the actual output. So few changes, actually 3-4 changes we did in the code. First change was, I guess, that the parameter name, we instead of taking num rows, we took it n, or you can take it num rows only. Second change was running the loop should be from 0 till row minus 1 to have the same indices. Then what we did was we basically tried to ensure that both of these indices, the x and the y, have exist, like they exist in the previous row, and if they do not exist, then don't take them 0. Default value should be 0. And one corner case was that if the first row is being added, then it should not be 0, otherwise all the pattern will remain 0. So we have to take row equal to 1, then add 1 directly in the first row. It should start from 1. So if I will submit it, let's see if it is working for all types of test cases or not. It is taking some time to run, and it is getting accepted for all test cases. But if there is a follow-up, can you try this problem using some mathematics? And the hint will be, can you try to figure out some binomial coefficient formula? Each of these terms will be associated with some binomial coefficient. That is, will be 0C0 or 1C1, something like that. This will be 1C0, 1C1, 2C0, 2C1, 2C2, 3C0, 3C1, 3C2, 3C3, 4C0, 4C1, 4C2, 4C3, 4C4, and so on. Every term will be a binomial coefficient term with some n, some r, NCR. So you can try it using the formula, but this was using a simple logic where every row can be constructed using the previous row. And with that, we are done with the problem Pascal triangle. But what is the time and space complexity? As you can see, we are running a loop on all the rows, so order of n. As you can see, we are running a loop on all the columns, and worst case columns can be n only, that is equal to rows. So n into n, the overall time complexity will be n square. And when we talk about the output space, since we are taking all of these lists, so what will be the overall output space? Output will be order of n square because it will be a matrix. But if we talk about extra space, there is no extra space as such. We are not taking any auxiliary data structure. This is just for the output. So extra space or auxiliary space will be constant. With that, now we will meet with a new problem in a new video. Till then, bye bye. Take care.